Okay. Hello, good morning. My name is Michał, and we're going to do some presentation about Formula One and machine learning. So my title of this talk is Predicting F1 Strategy Using ML.NET, or Michał tries to predict stuff that teams can't do very well without the data that they have, and I don't have really a journey. So my name is Michał, I come from here, this is northern Poland. This is a very beautiful picture that covers both Poland and southern Sweden and a bunch of Denmark, although under clouds. So around a decade ago, I moved to southern Sweden and work for a company called 37. We're a consultancy company focused on knowledge sharing, and we love to share knowledge with our community and our clients. We've been to NDC for over 10 years now, and we're very happy to present in front of you today. Me today and yesterday, our CTO, who's a renowned expert on Disney princesses. Okay, so just to manage expectations, so if you want, you can still leave. Today you learn just a tiny bit about machine learning, a bit about ML.NET, and more than you ever wanted about rubber. So yeah, let's start with ML.NET. Why do I even use ML.NET, since there are so many better tools for machine learning, right? Like .NET is not really known to be like powerhouse in the area, at least maybe not yet. So first reason is .NET. I come from this kind of technology. I did most of my work in .NET and C# and maybe a bit of F#. So when I want to like crack a bit of code, my natural instinct is just like open VS or VS Code and just write some C# if I want to like test something out. And yeah, Microsoft done a lot of good things in recent years about like open sourcing stuff and accepting contribution, and this product is run really well in that regard. And it's pretty good API. It's focused on problems you want to solve and not kind of what kind of arrays you want to multiply to, you know, or what kind of network architecture you want to do and stuff like that. It doesn't really support deep neural networks that well, but we'll get into that later. And yeah, it's pretty regularly updated. This year was version 2. We had release of version 2. And yeah, this is often my first step if I want to like, you know, look at some problem and see if this is something I can, you know, run some ML on this. You've probably seen already a few presentations about machine learning, and generally the machine learning job is divided in two parts. First, you kind of create your model, and that's the long-lasting job. First, like training takes usually much longer time, but first you have to like prepare the data, reshape it, and so on, pipeline. So ML.NET has some like tools for that. And the other part is like using that data to making some predictions, to creating some analysis and so on, so like inference. And that's usually much quicker job, and you usually want to do it like in separate task somewhere else. So when you train the model, you save it somewhere and you use somewhere else. You probably have some like regular running job to train your model every week, month, or something like that. And your web app is like using that model every second to make some predictions. And if you're really stubborn, you can put like ML.NET code, like whole model training and usage in one screen of PowerPoint. But probably you don't want to do it because first of all, you want to divide training from inference and so on. But just for the sake of showing how little code you need, that's some example. Although since version 2.0, the API slightly changed. The old one still works, but the new one gives you a bit more power. So sometimes you want to move in that way. So let's talk about this like pet project of mine. What was my approach to this? So I started with a GitHub repository that's like machine learning samples from ML.NET. This is like really cool repository. I link it later on Slack, so you don't have to look for it right now. Where you can see like different use cases. For example, like I think the one on the screen is like bike sharing prediction, which is like regression problem. There are some like categorizations problem, image recognition, language analysis, and so on. So you can start with those or find like a problem that's similar to those and just use that code kind of like a starting point. It's easier than just type from scratch. And the project plan in like early 21 for this project was like, okay, so like I'm still gonna start from this sample, and with like every race which happens like during season every week or two, I'll gather data from that race. So let's say first race is usually Bahrain. I'll get that race and maybe from the same race from previous years to have like some repetition and maybe start looking for some patterns. And then do some exploration of data, look at what's on the offer in terms of tooling, how can I like visualize the data, how I can do like some automated retraining and like ML operations. And yeah, eventually go from like one file script or like one PowerPoint page to something that's going to be nice, well architected app. So let's talk about Formula One strategy. And since Formula One banned in-race refueling in 2010, I believe, it boils down to tires. Like race strategy is bearing on the right tire in the right time of the race. So this like graph you can usually see after the race, which basically is on which position where each driver was during the race. And you can see some like sharp drops. For example, Lando Norris, the top orange line, has some sharp drops here and sharp drops here. This is where he goes to the pit stop to like change his tires. And while he's doing this, some other drivers overtake him, so he loses position. But there's benefit to changing tires because on the new tires he's getting faster. And apart from benefit, he also has to do it at least once because Formula One enforce to do one pit stop. So there's like few ways you can do it. You can stop once, and then you have like two kind of phases. We call them stints. So this is like one stop strategy with two stints. And somebody else can do like two-stop strategy. So we have like three kind of phases of race. But because of that you know, that person changed those tires more often, they can drive more aggressively over corners, go faster. They can usually use like softer tires, which gives them some benefits. So even though they spend more time in like pit to like changing the tires, eventually they end up on top at the end of the race if they manage to overtake. And sometimes something like that maybe happen, that like you have really slow stop, although we probably should switch those colors because that's usually Ferrari that messes up the stops. And sometimes, you know, we have like situations like there was accident on the track, there's safety cars, so all the other cars go slower, and maybe for you it's a perfect moment to like change your tires, and instead of like losing 23 seconds, you lose 16. So suddenly, you know, you gain like 7 seconds with maybe like 3 positions on the track. And this may be like decision between winning and losing the race. So initially I focused on period from 2017 and to 2021. And it was like good reasons for that. It was like tires used in that period were like pretty much the same. There were like minor changes. Pirelli is always messing a bit with those, but generally like in architecture they were the same. And the aerodynamics regulations was like pretty stable during that period. The cars were mostly the same size, same weight, and we had stable core group of like teams. So we didn't have any teams dropping up and joining, at least from the core group. So we have like data to compare over the years, which is always useful. And 2021 was like the last year of those regulations. The new regulations came in 2022. So it was like pretty good time to like play with this and maybe like do like, you know, good summary of that era. But like I've made that slide in 2021, and if you look at calendar, you like realize we may have a problem with the timeline of that project. But yeah, let's talk rubber. And I'm gonna start with this really confusing image from Wikipedia. But let's remove the wet tires straight away. When we have like wet races, the chaos occurs. Some of you may have seen last week. And there's like no way to predict that. It's probably pretty stressful moment for like team strategists to do. and it's impossible to predict what's going to happen. So let's focus on like dry tires. And on the left, you have like compounds. Pirelli designed 5 compounds, although there's like slight asterisk for this year for that, but let's focus on this. C1 is the hardest, C5 is the softest. But to not confuse people, or maybe confuse even more, they decided to just like label them with 3 colors. So for each race, they're going to pick 3 out of those 5 tires, and one is going to be the softest, one is going to be medium, and one is going to be the hardest. So for example, for Bahrain in 2021, they decided that C4, so it's going to be the softest, C3 medium, and C2 the hardest, so they kind of picked the middle of the pack. And for the Spain of that year, they decided it's going to be more hard compounds. It's because like it's a usually very hot race, so the tire degradation is higher, so they wanted to move them to like a bit higher. Bahrain is usually over the night, so even though it's like Middle East, it's not that hot as you think initially. And yeah, at the end of the race, you can like see a chart like that, which drivers use which tires over time. And I decided, okay, I'm gonna try to generate some data out of this, unfortunately manually, but we'll get into this. And the kind of desired output of this project would be like a set of strategies for each drivers or team, like what would be like fastest or maybe like second fastest option for them to run. But since we want to like minimize the scope of the project, like run of the MVP, first let's try to like predict how many laps we can do on like one type of tire. Let's say how many laps can Alex Albon do on a soft tire in Spain with you know, in the years like that. Okay, so we have first round of year 2021, Bahrain, fantastic race, fantastic track. And I manually generated a bunch of data. It's not much, it's around 230 rows. And in machine learning, the problem when we want to like create a function that takes input of some values and generate one value is called regression problem. We basically try to like match function to the shape of data we have. And okay, so I like take ml.net and just start to like setting up like what we need for a regression algorithm. And there's a lot of words category there, because a lot of data I have as my input is not numerical data, it's just names. For example, driver name is category, we have like 20 drivers. And well, for regression, categories is bad vibes. You don't want a lot of categorical data, because when you calculate a mathematical function, you want to like to output numbers. You want to like multiply some numbers by some numbers. We basically generate like a polynomial function, and that's all fun and games if you have like temperature, which is a number, or like humidity or stuff like that. It doesn't work like that when you try to like multiply Max Verstappen by 0.37, right? It would work in JavaScript probably. It would output something, but I have no idea what it would do in math. So we have to like do something called like one-hot encoding. So instead of like having like one category driver, we create 20 categories. Is Verstappen, is Perez, is Ricardo, and they have like values 0 or 1. So yes, we have now numerical data, which is good, but suddenly you have like, instead of one parameter, we have 20, which means for, mathematical parts, we have 20 more dimensions to calculate, which means for this algorithm to converge, we would need to have more rows, and I don't have many rows right now. So it's like, it's not a very good situation. Categories are not good for regression. We're not in a good spot with that data, but okay, let's play with it. Let's see what we get output. I get some outputs, and I can like compare line by line, but it's hard to tell. Some things look good, some things looks bad, but it's not so good. So let's look into statistics, and you can like output from ml.net the model statistics on your kind of comparison set. And loss function is used kind of like a relative thing to compare during training, but R squared is something more like good. Non-relative value to compare how good your model is. Usually it sits somewhere between 0 and 1, and you kind of want this closer to 1. And if it's negative, it's something like this. So yeah, first race. But yeah, the next race, the next week, teams come up with new inventions. I come up with new models. So let's bring up some updates for Imola and Portimao in that year. And this is, again, not very good situation because that was 2021. We still have like COVID raging around the world. So Formula One didn't travel to the usual tracks, so they added a bunch of like random, not very commonly used European tracks, like Imola and Portimao. Imola, for example, is like legendary track, and it's it's a sacred land for like Formula One. That's where Senna gave his life to the sport. But unfortunately, it's a very outdated track. It's not great for racing. It's a bit narrow at some places, and Formula One doesn't like to come back there, but because they were forced, they went to. And Portimao is a track that's, I think, mostly used for MotoGP, but, beggars are not choosers, so we went with this. So I can add this data, but it doesn't add a lot of value, because it's going to be like, I don't have a lot of repetitions for that tracks. But yeah, I added around 200 rows of data, 400 totally. And I started doing also some filtering with ML.NET, because like if the stint finished after one lap because there was crash, it's probably not very good stint for me to use in the training, right? I want to just kind of use successful stints, let's call them like that. So I started looking into like which ended with like pit stop, which ended with finish of the race, and did some filtering that forced me to like learn something new, how you do filtering in ML.NET, all nice and fun. We did some results. Some of them were not very good because that was a wet race, so yeah, no point of like predicting. The other one, like some things look very close, but again, let's look at statistics and yeah. Okay, so let's look at Spanish Grand Prix. And this is interesting tracks because Formula One used to test there a lot. The teams know this track very well, the drivers know it very well, which usually renders hopefully like boring racing, because teams are pretty much like very well prepared for this, and there's like no surprises. And to give you one example, Kimi Raikkonen over his like 20 years career spent like 88% of his laps during testing on this track, and only like 12 in the racing. And yeah. Yeah, we have a lot of new data, and started introducing AutoML, which is, there are a bunch of regression algorithms available in ML.NET, and you can just try one by one to see how they do with your data. Or you can even write a for loop to, go over them to see how you're doing with your data. Or you can just like do AutoML experiment that will do it for you. And if you're even that lazy, you can just, open your solution, right-click, add machine learning, load your data, and congratulations, you're a data scientist. Yeah, training, generating code, done, ship it. I don't recommend that, but maybe it's a good start. But something interesting happened, because we're on the plus side, right? It's still miserable, but okay, let's look for more data. And at that point, I was pretty annoyed with like manually generating that data. I was just falling behind the schedule. I was trying to block that along the way and so on. It's just like, I have like better ways to spend my weekend, right? And then I remember that there's this library, because there's like this weird signal error API that's like is posting racing data during the race, and you can just like tap into this and listen during the race. And there's like some group of people just like take it over and like cache it, and you can just ping that API. And it's written in Python, but like it's pretty easy to use. It has like charting built in, so you can draw nice charts of the stuff and so on. So all that time I was just generally manipulating data, and one evening on writing Python, and I have suddenly like 4,000 rows of data from all those years. So I don't have to like programming rules. So yeah, let's say we're still in 2021. I want to predict Zandvoort race. We had Zandvoort just last week, but I think that was the first year that that race came back. So it was, you know, I wouldn't like there was not much data to predict on top of that, and still somehow this algorithm converged to something. It's still not very good result, but it's significantly better than what we had before, right? So we're heading in the right direction. So now it's 2023, and what's the reality of this project so far? I started with samples, that was easy, and I stopped pretty quickly generating the data, but I found another way, so okay, that's a win. And I didn't do any of that because I'm still working on like 3 scripts doing this stuff. Of course, not in the well-architected app. And year 2022 happened, so we had like very big changes in Formula One. And one of them is like the biggest change in regulation of aerodynamics for like 3 decades. A lot of change to help, you know, cars follow better behind each other. And also tires change. Formula One moved from like, I think, 13 inches to 16 or 17 inches wheels, which makes the tire roll significantly stiffer, and those tires act completely differently, so like all that data is probably useless. But maybe it's worth checking. So right now I have around, I don't know, 6,000 rows of data total, and over 2,000 of them are like already past those choice regulation. So I started running those models, like including both, including only one, and so on. And it's, at this point, it's like inconsistent. I'm not sure, but probably just gonna tend to move towards the newer data because that's what makes sense. And there are a few problems to solve, like the categories problem that I mentioned. That it's not very useful. So one of the categories is track, and there are like 22 tracks a year. So it's another explosion of dimensions. But every week or every race, when Pirelli publishes their, the tires they're going to suggest for the race, they also publish some information about track that are some numeric information. So maybe we could use some of that, check how they're going to be useful. So instead of like using Monza as a category, I could just have like 2 or 3 numerical values of those dots that make sense. That would probably help a lot. So what's happening right now? I think something I tried to train it yesterday evening, but didn't finish it up, is try to model lap time over like kind of lifetime of tire. Because if you like predict that Alex Albon can do like 23 laps on the soft tire, this is somewhat useful, but you don't know how much you can push it. If you can do like 27 laps on that tire, does it make sense? Because the tire act weird. They're like black magic. They usually they start pretty much like underperforming at the start because they're not heated up to the like operating temperature. And when drivers start like driving them, they get like heated up and they like for some time operate in like optimal thing. But something starts to happen at some point, and that window is probably where you want to like pit, because after that it's what drivers call cliff. So the tires, instead of like losing half a second on the lap compared to like your opponents, you start losing like 7 seconds on the lap. So maybe at the left side of that blue field, you think like, okay, I'm losing like 1 second over lap, and we're gonna waste like 20 seconds on a pit stop. I would be catching up 20 seconds for that. But if you're like on the right side of the field, you start losing 7 seconds on the lap. That's only like 3 laps to catch up. So that's like significant consideration when you want to pit and like how much you can push those tires. Sometimes you can hear over the radio drivers saying like, what do you think about like plan plus 10, because they want to stretch that tire if the conditions change. So that's what's happening. And another thing is like pit stop times, because as we know, some teams are not really good at this game and some are really good, and pit stop from the lead to just get extra points just for the fun of it. And that's from that point, it's pretty much like packing rucksack with those information. How many time you take on the pit stop, how many things. It's like optimization problem. Another thing I saw people doing with that API is just using GPS data with some like calculus black magic to like calculate lateral forces on the cars and tires and so on, and basically doing like nearly 3D animations of cars going on the track. It's amazing from just amount of data that comes from here. And that could be like something pretty fun too, but we have to like dip into like black magic. So yeah, there is GitHub project with that stuff. I need to push that Python script, so if you want, you can generate the data I generated. And that was a bit speed run of this presentation, but we can take questions. Or not. All right, then I'm going to be here rest of the day. Feel free to talk to me later. And oh, yeah. Can you repeat? Sorry.
Yeah, how do you deal with the tracks changing? So you said you do like categorization.
Yeah, right now I do like categorization and one hot encoding, but it's like not a very good thing. And that's I had this like Pirelli slot. That's what I want to start using, is basically use some like information that instead of like using Monza as a category. You say, okay, this is a track with like really high degradation, with like a bunch of fast corners and so on, to have some numerical data instead of like categorical data. That's what I'm aiming at, but I don't know, haven't experimented with that much yet. All right, see you outside. Thank you.